Right, let me finish up the very end of this example that we were doing in class today, and then I'll kind of count that towards the time that we need to make up from Tuesday here. And plus that'll help you with tonight's homework. So we had gotten through doing the F prime sign chart, and we were starting to work on the F double prime sign chart. We took this 8/3 x squared to the fourth to the 1/3 power, and we took that derivative using the product rule. And one key thing in there is that we got this LCD, multiplying top and bottom of this first term by 3x squared minus 4 to the 2/3, and then that gave us an x squared minus 4 to the first power in the top, so that we just had polynomials. So then we set top and bottom equals 0, and we had our cutoffs here, -2, -1.55, 1.55, +2. Just getting ready to plug in some numbers here. So the -3, if we plug that in on the top, 5 times -3 squared, so that'd be 5 times 9, 45, minus 12 is positive, times 8 is positive, so the top's positive there. And then on the bottom, 3 squared here minus 4, that'd be 9 minus 4, that's positive. 2/3 power positive times 9 positive. So positive over positive, F double prime there is positive. And then the -1.75, that's a little tougher to do by hand, but actually you plug it into the calculator. So again, we're looking at F double prime, put -1.75 in here. Make sure you square it first and then multiply by 5 and then subtract 12. So this, you'll have to enter parentheses around your -1.75. So in other words, when you do your F double prime at -1.75, make sure that you do 8 times 5, and then it's the quantity -1.75 squared minus 12. And then same thing on the bottom, to make sure that your calculator squares a negative to get a positive. So this will be 9 times x is -1.75, and that gets squared minus 4 and 2/3 power. So this one, you can get an answer for the top and an answer for the bottom, or you can just get this whole answer and see whether it turns out to be positive or negative. When I did this, I got a positive on the top, and I got a positive on the bottom, which made this positive. 0 is a little easier to plug in. 5 times 0 squared minus 12, that's 0 minus 12, negative, times 8 is still negative on top. On the bottom, 0 squared minus 4 is negative, and you take that to the 2/3 power, so that's the second power and the cubed root. So you take a negative number to the second power, it's going to be positive, cubed root is positive, times 9 positive. This is negative over positive, which is negative. And then the positive 1.75, that's going to give you the same answer as the negative 1.75 because it gets squared here and squared here. So it doesn't matter whether this is positive or negative since it gets squared. So this one's going to be a positive over positive again. See, this answer that you get, this is going to be greater than 0, positive. And so that's a plus. And then if we plug the 3 in, 5 times 3 squared, so 3 squared is 9 times 5, 45 minus 12, that's positive, times 8, positive on top. And then 3 squared is 9, minus 4 is 5, 2/3 power is positive, times 9, positive on the bottom. So this is positive. So we're concave up, concave up, concave down, concave up, and concave up. So these two parts look a little bit weird here, but you got to go up above and look at your increase-decrease. Okay, so we're matching up increase-decrease with concavity. In fact, let me go back here and let's do it piece at a time. So let's bring down our cutoff of 0 right here, right there. So here f double prime is positive, so that's concave up. We look up above, we're decreasing. So decreasing concave up looks like this. Okay, between -2 and -1.55, we're concave up because this is positive. We go up here, we're increasing. Okay, so that's going to be increasing concave up. Looks like this. And then in between -1.55 and 0 right here, now our f double prime is negative, we're concave down. We look up here, we're increasing, so increasing concave down right there. Between 0 and 1.55, we are still concave down. Okay, but we look up above, we're decreasing, so decreasing concave down like this. And between -1.55 and 2, we are concave up now, positive. We look up above, to the left of 2, we're still decreasing. So this is decreasing concave up. And now past 2, f double prime is positive, concave up. We look up above, we're increasing. So increasing concave up like that. So now we can put the pieces together with the points that we've got. Notice here we switch from concave up to concave down, so we're going to have inflection here at -1.55 and another one here at +1.55. So we got inflection here. So for inflection points, you have to find the y coordinates. And I did that over here. If you plug in, this is the exact value for the plus or minus 1.55, and you go back to the original function and plug those in to get the y values of the inflection points. So I went back to the original function here, x squared minus 4 to the 4/3 power, plugged in my positive 1.55 and my negative 1.55, I got 1.87. So that means that your inflection points are going to be plus or minus 1.55, and then your y coordinate is 1.87. Okay, so let's sketch a graph here. Try and line it up with what we've got up here. So -2, -2 to +2. And remember, these are the places where we had our minimums and the function values were 0. At 0, that's where we had our maximum, 6.35. So -2, we were at 0. +2, we were at 0. At 0, we were up at 6.35. So this is 0, 6.35. And then at 1.55, so let's see here, that's coming down from here, 1.55, and also at -1.55, we are up at 1.87. So 1.87, this is 6.35, 1.87 would be about a third of the way there. So somewhere in here. So if we do, let's see if this is marked off in ones here. So this is 1, 2, 3, 4, 5. This would be just a little higher than 6. Fix that guy up. So about right there. Then -1.55 up to 1.87, about right there. And then +1.55 up to 1.87, about right there. So those are our inflection points here. So this is 1.55, 1.87, and then this one here is -1.55, 1.87. Okay, so here we are decreasing concave up, coming into this guy. And now we're increasing concave up. And then remember here, we went up here and we had minimum points at those two places, and f prime at ±2 was equal to 0. So that means that we've got horizontal tangent. Okay, if we plugged in 2 and -2 here into our f prime, we had 0, because this is 2 squared minus 4 is 0. And 0 times anything, 0 to the 1/3 power, 0 times anything is 0. So we've got horizontal tangents there. So those things flatten out. So I thought here that we might have a possible cusp. I'll show you why here in just a second. But this flattens out for a second, and then it's increasing concave up in between here. And then inflection point switches to increasing concave down up to this point, the maximum point. So that looks like that. And then it's decreasing concave down here. Then it's decreasing concave up. And now increasing concave up. So we're getting this W shape. It's a really nice W shape. We've got all our points marked here, our minimum points, our maximum point, and our inflection points. That's the important stuff. But we do have to watch at these zeros for the inside when you have a fractional exponent. So on the homework, you have one with a fractional exponent, and the numbers that make this inside function 0 are 2 and -2. Now watch what happens when we graph this thing. So here I'm in Scientific Workplace. We're looking at x squared minus 4 to the 4/3 power. And if I graph that in the default, it gives me a picture that looks like this. And what's going on is this thing just goes up like crazy on the ends. So we need to zoom in here a little bit. And we zoom in a little bit more. And oh, this is not graphing for values less than 0. So I actually need to rewrite this here as this is 4th power cubed root. So I need to do a cubed root on this. You shouldn't have to do that on your calculator. I think your calculator graphs those okay. Alright, so let's do that one more time. There we go. Okay, so let's zoom in a little bit more here. Okay, so notice here, this is concave up, and then it's kind of hard to tell here, you know, where the inflection points are. This is supposed to be concave up, but it almost looks like we have a cusp down here. And it almost looks like we have a cusp down there too. It looks like this is concave down all the way to here, but then concave up. And if you graph it on the TI 83 or 84, it looks the same way. If you look at it, you'll see these things, you know, it's kind of hard to tell whether it comes down to a cusp or whether it levels out for horizontal tangent. So, and usually with fractional exponents at those places, you know, 2 and -2, which are zeros for the inside, you can sometimes have cusps. So, but if we do successive zooms on this, what we'll see here is that it flattens out even more. You know, so you see this flattening out a little bit more. So even though this is concave up and concave up, here it's not making a real nice flat, but it is flattening out here to horizontal tangent. Okay, it's just not quite as nice as a polynomial. Okay, so the graph can be, you know, a little bit deceptive on your calculator, so you just want to kind of watch for that. So in the one that you do for the homework, the problem number 29, the key is to get that common denominator after you take the derivative. And then on yours, I think it does actually have a cusp. So here, in this case, no, this didn't happen. We didn't have a cusp. But on problem 29, watch for a cusp at places that make the inside of the fractional exponent equal to 0. So, all right, we'll take a look at that one tomorrow.